Welcome to this explainer. Okay, I want you to step right into the drafting room with me today. Put on your lead engineer hat because we are looking at the absolute ultimate blueprint for a legendary high-performance machine, the Suzuki Hayabusa. As engineers, we don't just look at a motorcycle as a mere vehicle. We look at it as this complex, beautifully orchestrated series of solutions to physical problems. And in this explainer, we're going to tear this iconic machine right down to its studs. We're going to understand exactly how its core components work together in perfect harmony. All right, let's dive into this. 299. Yeah, in kilometers per hour, that is over 185 miles per hour. Absolutely wild. But here's the thing, this isn't just a top speed. For us, this is our central engineering problem. How do you propel a machine to 299 kilometers per hour, keep it glued to the tarmac, and somehow keep the rider completely in control? Every single nut, bolt, microchip, and metal alloy we're about to talk about was chosen specifically to solve that one equation, extreme speed. So solving that speed equation, well, it absolutely has to begin with one thing: massive, unadulterated power. To shatter that 299 kilometer per hour benchmark, a standard engine simply is not going to cut it. No way. We require a massive 1,340 cubic centimeter powerhouse. This right here is the beating heart of the Hayabusa. It's a displacement so large it literally rivals small family hatchbacks, but we've compacted it into this incredibly dense footprint that sits right between the rider's legs. But, before we get into the guts of that engine, we need somewhere to actually put it.
Which brings us to Section 1, the foundation, engineering the chassis.
Think about it. When you have a 1,340cc engine generating that kind of violent power, the immense torsional forces could literally twist a lesser motorcycle apart. We need a skeleton that can handle that kind of massive stress without weighing the bike down like a boat anchor. So the solution to that weight versus strength dilemma? The twin spar aluminum frame. This is our heavy-duty structural skeleton. By using twin spars, which are these massive beams that basically wrap around the engine, we create a perfectly rigid cradle. And aluminum is absolutely the material of choice here. It gives us incredibly heavy-duty structural integrity while remaining phenomenally lightweight. This frame dictates the motorcycle's handling, its stability at those extreme velocities, and gives us the perfect, unshakable foundation to build upon.
Now, notice the juxtaposition here between our rigid internal aluminum frame and the external aerodynamic plastic bodywork, the fairings. The front, side, and tail panels aren't just there to look aggressive or cool. Actually, they are mathematically sculpted to manipulate air resistance. While our skeleton handles all the mechanical stress underneath, these external fairings form the bike's iconic shape, allowing it to punch a perfectly clean hole right through the atmosphere.
Let's look a little closer at how we actually slice through that wind. Up front, we've got this meticulously angled clear windshield. At 299 kilometers per hour, the wind isn't just a breeze, right? It's literally a physical wall trying to tear you right off the bike. So this clear windscreen is mathematically angled to deflect that high-speed air directly up and over the rider's helmet. And moving to the back, we have the rear seat cowl. This is a removable plastic cover that completely hides the passenger seat. It essentially transforms the bike into a slicker, sportier solo profile. Less drag, cleaner airflow, more speed. Moving on to Section 2, mastering performance mechanics, harnessing power. All right, so with our structural foundation set and our aerodynamic skin applied, we've got to dive deep into the engine and transmission mechanics. We need to see how we actually harness that raw power. Follow this dynamic mechanical flow with me. Step 1, inside the cylinder block, fuel burns violently, driving the pistons up and down. Step 2, that violent vertical motion is instantly captured by the crankshaft, converting it straight into rotational energy. It's just spinning furiously. Finally, step 3, we have to deliver that spin to the wheels. The clutch assembly seamlessly connects and disconnects this power, feeding it directly into a highly precise 6-speed gearbox. This gearbox completely manages the power delivery, allowing the rider to multiply torque depending on their speed. It is just this rapid, continuous cycle of controlled explosions being translated into forward momentum. But, here's the catch. Capturing all those explosions generates an immense, critical amount of heat. If we don't manage it, our 1,340cc beast will literally melt itself from the inside out. Enter our thermal management. A massive radiator and highly efficient liquid cooling system are engineered to keep temperatures right in the optimal zone. Meanwhile, the byproducts of all those explosions, the exhaust gases, are violently expelled through the Hayabusa's signature dual exhaust pipes. Those are the twin mufflers flanking either side of the rear wheel. Okay, let's take a breath for a second. We've built the frame, we've engineered an engine capable of unthinkable momentum. We've hit our top speed.
But now, we have to pivot sharply to a matter of absolute life and death engineering. How on earth do you stop a 1,340cc powerhouse flying down the road at 299 kilometers per hour? Which brings us to Section 3, Taming the Missile. Control systems. Going fast is actually relatively easy. Safely taming that momentum requires a masterful control arsenal. We have to meticulously design the suspension and braking systems to keep our high-speed creation totally stable and safe. For our suspension, we employ inverted or USD front forks. These are incredibly high-performance shock absorbers that keep the front wheel absolutely planted, eliminating any of those terrifying high-speed vibrations. At the rear, an adjustable monoshock absorbs impacts while maintaining relentless traction. These components ensure that no matter the road surface, the chassis remains perfectly stable and the rider remains completely in control. But when it comes to actually scrubbing off that speed, we rely on elite stopping capability. We equip this machine with premium dual-front Brembo-style calipers. Seriously, top of the line. When the rider grabs that brake lever, these calipers bite down with incredible hydraulic force against dual-front metal disc rotors, alongside a single rear rotor. The sheer friction generated here is astonishing. It converts the kinetic energy of the motorcycle right back into heat, generating enough sheer friction to literally glow red hot, safely bringing our missile to a complete halt. Of course, all that horsepower, all those beautiful aerodynamics, and all those massive Brembo brakes, they mean absolutely nothing without traction. The whole shebang relies on the final contact patch. We use lightweight alloy wheels to reduce rotational mass, which allows the bike to accelerate and change direction so much quicker. But the real heroes here are the high-speed tubeless tires wrapping those rims. These are definitely not your standard rubber. They are highly specialized compounds engineered specifically to withstand the blistering heat and massive centrifugal forces of traveling at speeds exceeding 299 kilometers per hour. And finally, Section 4, the Command Center, Electricals and Electronics. To tie all of our mechanicals together, a modern hyperbike needs a nervous system. We're talking about the Command Center, where the human rider actually interfaces with these complex physical systems. And right at the center of that is the Engine Control Unit, or the ECU. Consider this the absolute brain of our operation. The ECU is a central computer constantly reading data from dozens of sensors. It's making split-second decisions, adjusting the fueling and the ignition timing hundreds of times per second. It ensures the engine is running at peak optimization and manages advanced rider aids to keep the rider safe, even when they are pushing the absolute limits of physics. All of this incredible data converges right in front of the rider. The instrument cluster is this beautiful hybrid of the past and the future. We merge classic, sweeping analog dials, which, let's be honest, give you that visceral, immediate sense of climbing RPMs, with a modern TFT screen that digitally displays your ride modes and exact speeds. And, cutting through the darkness ahead, the bike relies on high-visibility LED headlights and taillights, ensuring maximum safety for any night operations. So what is the big takeaway from this explainer? It's how beautifully holistic this machine truly is. The lightweight twin-spar chassis, that monstrous 1340cc engine, the elite Brembo control systems, and the supercomputing ECU, they don't just exist next to each other. They work in perfect, high-speed concert. It's a total engineering triumph. But looking at all we've achieved with this legendary machine, it leaves us with a pretty provocative final thought. As materials get lighter and computers get even faster, where does hyperbike engineering go from here? How will engineers conquer the next frontier of speed? Think about that next time you see a machine like this out on the open road. Thanks for joining me on this deep dive into the engineering of speed. Keep questioning, keep learning, and I'll catch you in the next explainer.